Here we are. So, who found something that understand Michael?
So for me, it's all just the plugging in the equation. That did
I'm not sure what it is.
like where you get the graph.
When you write the equation of graph, all right, so let's look.
Like I give you an example in my head.
I don't, well, this is episode. I don't think, I am on the practice test. And I told you your focus needed to be on the pre-test, the thing called pre-test. We did most of that, or some of that yesterday. And then the thing called practice test. So on the practice test, I am looking at problem number 10. Now, all of these problems are done exactly the same way. So whether you have done this one or not before doesn't matter. It's the process that you have to pay attention to. So we are going to write an equation for a sine curve and a cosine curve. And it doesn't matter which one you do first. You know that they're going to have a tremendous amount of stuff in common. So we're just going to pick one, get it written, and then we can do the other one. Oh, I don't have a picture. So when you see that shape, I don't know, what do you think of? What do you want to write first? I think of sine. When I look at that, the way I drew it, I started doing it like that. So I'm going to write a sine curve. If I am looking at this part right here, and again, you can look at other parts. Your answer will be different. But I'm going to look at the first part. That is a positive sine curve with an amplitude of 4. It's supposed to start here, but it starts over here. So that means my horizontal or phase shift is actually negative pi over 6. But in the equation, it's x plus pi over 6. That shifts me up. Right? Since I'm oscillating between 4 and negative 4, this is the midline or the axis of the problem, so I haven't lifted it up. If I lifted it up, it would look like this. It would be oscillating up here like this. You see that? This one is not, so there's no vertical shift. I don't know what this number is. The other ones I can kind of look at it and tell. I don't know what that is. But I know that 2 pi divided by that number gives me the period of my graph. One hill, one valley. That's negative 1/6. This is 3/6. So negative 1 to 3 is 4/6. So my period, you can reduce that if you want or just leave it, 4 pi over 6. Beginning to end. Hill, valley. So when I solve this, so 12 pi equals 4 pi n. Solving for n, it looks like n equals 3. Now the cosine is exactly the same. What part are you looking at if it's a cosine? Want to start right here?
Yeah.
Do that. Well, that's a positive cosine, so this is going to still be a positive 4. If for whatever reason you decided to start down here, then you would have a negative cosine. And you can start there. There's no rule that says you can't. You can. If I start here, though, that is exactly where I'm supposed to start. So there is not a horizontal shift. There's obviously no vertical shift, and this number is a 3. Okay? That is the process. Regardless of the numbers, doesn't matter, that's the process. Okay? Who else found something? Either on the pre-test or the practice test? Yeah, Erica?
The page 3, the number 14.
So that is the prep. Oh, wait. Okay. Okay, I really want you to focus on the pre-test and the practice test, but I want to answer all those questions first, and then I will do, oh, actually, I think 14 is covered on those pages too. So, number 14, this says find 2 angles coterminal with pi over 7. How do we find coterminal angles? Add 2 pi, if it's in radians, we add 2 pi and we subtract 2 pi. So since that's a fraction, I'll need to get a common denominator. So that'll be 14/15 and negative 14/7. So again, whatever angle you're given, to find coterminals, you add a revolution, subtract a revolution, add 2 pi, subtract 2 pi. If that angle had been presented in degrees, I obviously wouldn't be adding 2 pi, I would be adding 360. Yeah. All right, anybody else have something on the practice test or the pre-test? Which one? Royce.
Number 2 on the pretest.
Pre-test number 2.
Or yours?
Now, when the little starred things I told you yesterday, that secret code for use your calculator. So this is a calculator problem. So secant 11 pi over 7 and okay, so I'm just gonna type this, oh shoot, 2 things. First of all, I can't type this on my calculator because I do not have that button. So how do I put a secant into my calculator? No, second, stop. Stop. When do I use second?
To find a degree.
When I'm finding an angle, right here. That right there, that's second.
You do 1 divided.
I do 1 divided by. Secant is the reciprocal of the cosine. If you are typing a secant on your calculator, there is no other way to do it. It's 1 divided by cosine. Now, see that angle right there? Is that a degree or a radian? It's a radian, so I gotta make sure my calculator is set in radians. It is. And then I'm going to do 1 divided by cosine. 11 pi, use the pi button, it's under the clear button over here, divided by 7. And you should have gotten 4.494. 1 divided by cosine, that's how you put a secant into your calculator.
I don't understand why you couldn't do in your calculator cosine 7 divided by 11 pi. Wouldn't that be?
No, that's like saying, like, let's have it not a fraction, let's say we wanna find the secant of 60 degrees,
Yeah.
okay? So let me just show you, so 60 degrees looks like this. So the cosine of 60 is 1/2. Do you agree with that, Jimmy? Which means the secant of 60 is 2/1,
Yeah.
right?
Yeah.
So see how that is 60 and that is 60?
Yeah.
I don't take the reciprocal of the angle. This is an angle.
Okay.
I don't reciprocal an angle. I didn't do 1/60th.
Yeah,
I flipped the function. You flip the secant,
okay.
not the angle. You're never gonna change the angle in the problem.
Okay.
Okay, ever. Millions and millions and millions of students before you have tried to figure out other ways to do this problem. There is no other way. Secant is 1 divided by cosine, period. Okay, no more discussion. All right, let's do the second one. This one right here. Now, do I have this button? I do. So I am just gonna press that button. Now, if I leave my calculator in radian mode, then, oops, forgot to put in the number, negative 2/3. If I put my calculator, leave it in radian mode, I get negative 0.588.
Pardon the interruption. Can you please send Harper Albers to Student Services?
Yeah. Come back as soon as you can, okay?
Thank you.
sweetheart? Okay. All right. Run. Now, somebody said a minute ago that when I see this notation, it means I'm finding an angle. There is nothing in the problem that tells me whether that angle should be in radians or degrees. So this would be the radian measure. Could I move my calculator into degree mode and get negative 33.690 degrees? They are both perfectly fine answers. This one, it has to be in radian mode because that's a radian. But here I have no idea. I just know I gotta get an angle and it doesn't matter how you answer it. Could be either one. You see the difference between these two problems? That is a radian. You must be in radians. All right, good. Finn, did you have your hand up?
I just had the next question I wanted to make.
Yeah, which is?
Number 12 on pretest.
Pretest number 12. Oh, I think I did that yesterday, Finn.
Oh, shoot.
Yeah,
Alright, my
look
bad.
in your notes and see. Let me see, is there one like that on the practice test? No, I don't see one. Oh, yeah, I do. Number 2 on the practice test, problem number 2. How do I find the period of something like this? You are not going to have to graph that unless it's on your calculator. You are not going to have to sketch this. But you are going to have to be able to find the period of it. All right, so what do? What are the steps we go through? You find the period of each one. So cosine, doesn't matter. They're both cosines, and so they start out with a period of 2 pi. This one's divided by 3. This one's divided by 2. So that means every 2 pi over 3, just keep adding 2 pi over 3. Every 2 pi over 3, you're going to repeat that one. Every pi, that reduces to pi, just keep adding pi. Every pi, you're going to repeat that one. Find the first number where they match. The first number where they match is right here, right? And so what's the period? 2 pi. Right?
Yes.
Ben, got it? All right, Blake?
How do we explain if you're sinusoidal or not?
This one is not sinusoidal.
Yeah.
Because the period of the first piece of the problem does not match the period of the second piece of the problem.
Okay.
If they're sinusoidal, they have to have the same
Is there
period.
any specific language we need to
Just
start
start
with, or you say the first part of the problem?
First has a different period than the second
Like
part.
the number before that. I know there's a specific yell that, the number before that.
What else? Jackson, is your hand up?
No, good.
Erica?
13, C, on the pretest.
Pretest 13C. Robbie is walking at a pace of 2.5 miles an hour towards the building. Alright, so here we go. Here's the building, and here's Robbie. At one point, his angle of elevation to the top of the building is 54 degrees. Robbie keeps walking, and then he looks up, and now his angle of elevation is 62 degrees. How tall is the building? Now, the key thing here is, though, Robbie walked for half an hour, right? At a speed of 2.5 miles an hour. So how far did Robbie actually walk here? 2.5 miles an hour for half an hour. 1.25. Okay. Well, I'm gonna call this thing right here, this Y, I'll say Y. Would you agree that tangent 62 equals X over Y? And would you agree that tangent 54 equals X over 1.25 plus Y? We did one of these in our notes. What do they got here? There's two equations with two variables. So I use substitution or elimination, probably substitution. So if I multiply this over, I have y tan 62 equals x. Just multiply it over this side. If I multiply this over, I have 1.25 plus y times tan 54 equal to x. Multiply this over to here. Now you know what I'm gonna do. Since they're both equal to x, I'll set them equal to each other. So y tan 62 equals, I'm gonna distribute this. So 1.25 tan 54 plus y tan 54. This is a quantity, was 125 plus y, so I'm going to distribute tan 54 times those pieces. Now, anybody remember what we do now? I can't factor because why? They're not on the same side. So I gotta get my y's onto the same side. So y tan 62 minus y tan 54 equals 1.25 tan 54. As soon as I get them on the same side, now I can factor them out. So y tan 62 minus tan 54 equals 1.25 tan 54. And then one more step, and then we're gonna have to type it in, which is a challenge also, but now we're gonna divide by that parentheses, right? All right, everybody still with me? So now I'm gonna type it in. So first of all, these are degrees, so make sure you're in degree mode. And then listen. every time you hit tangent or sine or something, it's gonna throw in that parentheses automatically. You have to close that parentheses every time. So for all of these, you're gonna have to close those. Second of all, this, you are dividing, this is a division, you are dividing by this whole thing. So that needs to be in parentheses. So you're gonna be doing a lot of parentheses. I think I have them all written down here though. So if we type that in, we should get it. 1.25. Okay, I'll tell you what I got, and then you tell me if you match. I got 3.411.
Where'd you get?
Does that sound right to anyone? Okay, be careful, not the answer to the question. The question is, what's X? So look right here. In your calculator, you have Y. So just hit times tangent 62. And X is 6.416. Now this is a totally made up problem because the unit on that is miles. So that building is 6 miles tall. Yeah. It's a, I made it up.
How'd you get that? Yeah, that, sorry, I zoned that one.
Y is in my calculator. Multiply it by tan 62. You can do that. That's my mouth. Yeah, but this one's gonna be harder because it's not. Yeah. All right, what else? Who else found something in your, as you were studying? Pretest number 7. This is a calculator problem. Problem number 7. We have done some of these without a calculator, but not this one. So here we go. What is this telling me? What is this telling me right there? I'm over the degrees, right? Tells me my calculator is going to be set in degrees because 360 is a degree number. Look at number 8. For number 8, it's exactly the same kind of problem, but this one's going to be in radians, right? So this is a degree problem. 3 tan minus 7 equals 10. So tan equals 17/3. Would you agree with that? This is why I need a calculator. I don't have a triangle memorized with 17s and 3s. Now, if that were root 3 and 2, I'd be all set. But I need a calculator to handle this. Either way, I gotta figure out where can it happen? Which quadrant can the tangent be a positive number? For sure 1 and 3. Tangent is y over x. Both positive, both negative. Gonna end up with a positive fraction. Okay? Now I'll go to my calculator, in degrees. Yep. And do second tangent, because aren't I looking for the angle? And what button do I press when I'm looking for the angle? Second tangent or whatever, sine, whatever. So second tangent, 17/3. And I got actually 79.99. 2. Did you?
Yeah.
This angle is always going to match. So now you just just need to figure out what is that third quadrant angle with a reference angle or a little angle here of 79.992. How will I figure that out? 180 plus. 180 plus. It's past 180. So it's 180 plus. So 259.992. So there are the two answers to that problem. Now, number 8 would be exactly the same, only I need to be in radians for number 8. That's the only difference. So cosine equals 1/4 if I did my arithmetic correctly. This is number 8. Where will that happen? Before I go to the calculator, I want to know where I'm going to be. Where is the cosine going to be a positive fraction? Certainly quadrant 1. Where else? Quadrant 4. Why is cosine positive in 4? Because cosine is x. And x is positive there. So my answer is going to be this red angle and this purple angle. Now the red one is going to come straight from my calculator, so I'm going to set it in radians. Radians. And what am I going to type in? Second cosine 1/4. 1.318. So this guy is 1.318. And so is this guy. But my purple answer is this. Now how will I get that? So one answer is 1.318. What's the other one? What? 2 pi minus. 2 pi minus 1.318. So on my calculator, I'll just take 2 pi minus that answer, and I get 4.965 as my second answer. This is 2 pi all the way around. I didn't go all the way around, I stopped. 1.318 short. Jackson?
Can we do 13E on pretest?
13E?
Yep.
Says find the area of the shaded region and the length of the arc determined by the number. Okay, so here's the shaded region. What is the angle of the shaded? This one's kind of tricky, because 105 is not the angle of the shaded. What is the angle of the shaded? 360 minus that, which would be what? 255? So the actual angle for the shaded part is 255. Does everybody understand that? And I'm doing the shaded. So 255 3/60ths. 255 out of 360 is shaded in this picture. Agreed? The whole circle, if I talk about the entire circle, that would be pi r squared. What is my radius? 4? So that would be 16 pi for the whole circle. I don't want the whole circle. I don't want half the circle. I want 255 over 3/60ths of the circle. Where did this come from? What's that? Pi r squared. That's the area, the whole thing. So now I'm going to simplify. So I know 4 goes into that and that. 2 goes into that and that. 5 goes into this how many times? 51? Alright, so this is getting to be a mess. I'm down to 51 over 9 times 2 pi. So 3 goes into there, 17 thirds. I got 34 pi over 3. Now you'll have a baby calculator to help you with that arithmetic, but all that is just reducing the fraction. This is the problem right here. And that would be square centimeters. That's the area. Everybody good with that? Now we're gonna find this arc right here. That arc. Two-part question. Area's done. How do we find arc length? The length of an arc.
Radius times radius.
Radius times radians. So I know my radius is 4. My angle is in degrees. So I'll change it. And I'll change it by remembering that pi is always 180. Pi radians is 180 degrees. So what is 105 degrees? Pi goes with 180, what goes with 105? So I'm gonna have some more reducing to do. So let's see, that's 5 goes into that 21, 36, 7/12. Not the answer. 7/12 is the radian. So now I gotta multiply that times 4. And I'm gonna get 7 pi over 3 centimeters, because that's gonna get. Okay, so I don't want you to get bogged down. There's a lot of arithmetic here. You know how to do the problem. That's what you gotta be able to do. All right, good. What else?
Wait, what's the point of doing the other stuff?
What?
Like, why would you find the 34 pi over 3? Just couldn't you just
Right,
automatically?
it's a two-part problem.
Uh,
It says find both.
uh,
You don't need that to find arc length, but it's a two-part problem. It says find the area and then find the arc length. So his point is, if all you had to do was find arc length, you wouldn't have been doing this, right? That doesn't have anything to do with it, but it was part of the problem.
so the ones that aren't shaking.
All right, what else?
Find exact values.
Come on. Erica?
Could you, like, make up one that we all, like, got wrong on the quiz?
I have no idea what you all got wrong on the quiz. What are you talking about?
Okay, never mind.
I mean, everything you need to know is on these sheets. So what did you miss on the quiz? And we can pick one off the sheet. Find one, we'll do it.
Can we do 11 on practice test?
Practice test number 11. Says answer this question in radians. What am I looking for? I'm looking for the angle whose tangent is 5/6. I'm gonna set my calculator in radians, and I'm gonna type it in. Yep, so second tangent 5/6. Second tangent 5/6. 0.695. Calculator problem. Yep.
second, on the practice test, the second one, A,
So 1A.
yeah, but not the one at the,
On the bottom right.
on the bottom, yeah.
Oh no, those are the answers.
Oh, okay.
So that is the answer to 1A. Yeah, so that's clearly in line. I have answers worked out to all these, and I just, to save space, I just put it on that paper, but yeah, those are answers.
Okay, I thought they were questions.
That's
8 on
all
the practice test.
What?
8 on the practice.
8?
Yeah.
Sketch 1 period and list all of the stuff.
Tired?
So what do we got? We have a cosine. Now, two things. Well, one thing for sure to note about this is the 1/2 is already factored out. Remember, you cannot graph. You can't get your phase shift right. You can't graph unless that number is out of the parentheses. This one's already out, so I don't need to worry about it, but if it had been in here, I would need to pull it out before I started. Okay. I got a positive cosine. So I remember what that looks like. That is a hill, part of a hill, half a hill, a valley, and the other half of the hill. That's a cosine. That shape, but shifted so that it's starting at higher rate to the right. Amplitude is 2, so it's actually starting here. Here's the top of the hill. It should be over here, but now it's over here. So there's the half of the hill, there's the valley, there's the other half of the hill. Now I need to figure out all these labels. In order to do that, I really need to know where I end. So that's, I need to know the period. And how do I find the period of a sine or a cosine? 2 pi over n, but this time I know n. 2 pi over 1/2, which is 4 pi. Now, don't make that 4 pi. That is not 4 pi. That's from here to here is 4 pi. So this is going to be pi over 8 plus 4 pi. So I'll get a common denominator. So 33 pi over 8. When you add fractions, boys and girls, you gotta have a common denominator. Get the common denominator. Now, this one right here is gonna be the average, or the middle, of 1 and 33. So 1 and 33 makes 34. Half of that is 17. 1 and 17 makes 18, and half of that is 9. 17 and 33 is 50, and half of that is 25. So there's the sketch. There's no vertical shift, so I am done with the sketch. What is my amplitude? 2. My period, I already figured out, that's 4 pi, which means my frequency is 1 over 4 pi, because what's frequency? Reciprocal of period. My phase shift or horizontal shift is pi over 8, and my vertical shift is 0. No, right? 0.
Can you explain why the dot starts on the right side of the line instead of behind the line again?
What we learned, I mean, it just is. X minus is a move to the right. X plus is a move to the left. When you write the equation, if any of these turn out to be 0, you don't have to include them. I always do, because when I set up my format, I've got these blanks that need filled in, but you don't need to put a zero.
I keep forgetting this. So if we define the, like, the n power, will be like 2 pi over n, and then will be times that negative. You know what I'm talking about?
Equals a period. Equals a period.
How,
Times it by anything.
how would we find n? I know, yeah, what are we cross multiplying is what I'm asking. Like, I forget what.
2 pi over n equals the period. I don't know, 5 pi over 8, whatever the period is. But I knew n, so that
Yeah, so I'm trying to, I just like want to remember what, if we like did this, what, how to figure out what to fight.
Okay, what else? Come on, what else? I'll just pick one. In which quadrant is sine positive and cosine negative? In which quadrant
2.
is sine positive and cosine negative? Because what we're really asking is, y is positive and x is negative. Think about sine as y and cosine as x, and then it's easy. And what does that happen? Quadrant 2. No calculator. This is a no calculator problem. What does this mean? What does that mean? It's no calculator.
You're gonna have to put circles.
We have to figure out where the cosine is 0. There is an angle. I'm looking for the angle where the cosine is 0. So I'm gonna go around my circle. I'm gonna start here, and go up and around, and I want the first answer where the cosine is 0. Pi over 2. Because cosine is x, and x is 0 right there. Alright, so start at 0, go up and around, keep going till you find what you want.
Would it be wrong for down there?
Yeah, it would be wrong. Because
Isn't that
that's
the-
why I'm emphasizing go up and around, first one you hit is the answer. Remember, that notation is only quadrants 1 and 2, so it really makes
Yeah,
sense.
yeah,
to
cause
go
it's
down
second,
there.
yeah,
Alright, let me find another one.
What is,
How about this one?
so it's asking what is x 0? So 0. Yeah, this is the first one. So you
No.
what's the answer? I think it's just 0, yeah. Or,
Alright, here
I
we
would
go.
because that represents 90.
No calculator. No calculator. How do I even start?
You're gonna do tan on the graph, you're gonna make a graph, you're
Make
gonna
a
go opposite
picture.
or adjacent.
And it's gonna be in quadrant 1 because inverse tangent positive, inverse anything positive is 1. Opposite over adjacent is 4/3. This is not a 30 or anything like that, but it's okay. I can find this. A squared plus b squared is c squared.
So it's 5, so then
Right,
it's
that's a
4.
special called a Pythagorean triple.
Then just roll it.
I still don't know that angle, but it's okay, because what I really want to know is the sine, and the sine is opposite over adjacent. Or opposite over opposite. Opposite over opposite.
I think we're done.
No, we're not done.
I'm on fire right now.
Another no calculator problem.
But,
No calculator.
alright, so that's gonna be a circle again.
So 3 pi over 2, isn't that one of my
yeah, it is.
quadrantal angle on an
That's
axis.
undefined.
So it's this one down here, right?
Undefined.
0, pi over 2, pi, 3 pi over 2. Or change that to degrees, it's 270, 0, 90, 180, 270. Either way, you're down here, and that point is 0, negative 1. Right? So x is 0, y is negative 1, and r is 1. I want cosecant. That will be on your sheet if you can't remember, but the cosecant is r over y, reciprocal of sine. So r over y will be 1 over negative 1, so the answer is negative 1.
I just need to make sure I didn't do too much.
We're going to, no calculator, we're going to graph this, no calculator. Now, the good news is, there's no shift of any kind. So tangents have an asymptote, and go through the origin, squiggle. And the normal squiggle is up through the origin, but because of that negative, we're gonna have to come down through the origin. So a tangent will always go through the origin unless you shift it. If you shift it, it's gonna go through that point. So if it had a, plus pi over 3 here or something, then that dot would be over here at negative pi over 3. All right. Now, what is a normal period for a tangent? Normal asymptote to asymptote is pi. So the normal period is pi. But we have taken that pi and divided it by 5. So that means here to here is 1/5. All right? Right smack dab in the middle is 0. The whole thing is a 1/5, which means we're gonna go how much each way? If the whole thing is a 1/5, we're gonna go a 1/10. Because what's a 1/10 and a 1/10? A 1/5. This has to be a 1/5. Right? So you gotta split it in half. Go half of the 1/5 this way and half of the 1/5 this way. So this is gonna be negative a 1/10 and positive a 1/10. Because the whole thing has to be a 1/5. If you went a 1/5 each way, do you see what would be wrong with that? That would be 2/5. And you can only do 1/5. Okay.
That'd be 1.
So what's my amplitude?
None.
None, no amplitude. My period is, I just figured it out, pi over 5.
Yeah.
Which means my frequency is 5 over pi. I have no shifts in this problem. So vertical and horizontal are 0. Can I help you?
Yeah, you found it in the hallway.
No, I'm sorry. None of you found a gold bracelet in the hallway, did you? Yeah, I'm sorry to say that.
Wait, oh.
Alright. Fine, okay. Number 14. We have a flying squirrel on the top of a tree. The tree is 18 feet tall. His angle of depression is 27. That's where you're putting it. How far is the squirrel from the nut.
Sine 27.
Make sure that your calculator is set in degrees. That is a degree. So we'll multiply by x and divide. We will miss that problem if we're not in degrees, so make sure you're in degrees. And the answer is 39.648. All right. We should absolutely not miss this problem. What is the sine of 5 pi over 4? No calculator, 5 pi over 4. So, what do we know about 5 pi over 4? That's an angle. It's not 60 degrees. It's a 45, but it's 5 times 45, so it's 225.
Can you just do 5 times 180 divided by 4?
You will have a little calculator to help you. Pi is 180. So this is 180 divided by 4, which is 45 times 5, 225. Now, 225, not there. 225 is down here. This is 180, this is 225. How big is that angle? 45. 4 pi over 4, if you're in radians. So 1, 2. Be careful, these are both negative.
Oh.
Why are they negative? Because we're in the third quadrant. In fact, if your picture is not in quadrant 1, something's going to be negative, right? Make yourself put those negatives in. We want sine -1, so we have to.
Oh, I was the negative on top, like top of the book, and someone, like, why is that negative? Yeah, but I was the one on top negative. I know, I never looked at
Right now,
the one right there.
Because you're the negative, not one.
Sometimes I'm
You're an idiot. Yeah, but look what pretty lucky. I was sleepy.
Alright.
Royce, I was sleepy.
There are office hours tomorrow, but we have required meetings on Thursday and Friday. So office hours are tomorrow.
This morning, are we short? Wait, no, that's Friday.
So we have